Alright, Chapter 12, Section 3, Inscribed Angles of Circles is what we're going to be looking at. So, inscribed angles. So an inscribed angle is an angle whose vertex is on the circle. Okay, so it's on the circle, not just inside the circle. So an inscribed is going to be on that circle. Okay, so in this case, ABC, angle ABC, would be an inscribed angle. Okay, so the angle of the measure of an inscribed angle will always be half of the intercepted arc. So if this arc AC was, let's make it 50, okay? Let's say that measure was 50, that means that the angle at B would end up being 25. It's always half of what it is. So if you know the intercepted arc, you cut it in half, and that's the measure of the angle. The reverse works also. So if you know the measure of the angle, then the arc is going to be double that. So if we know that the angle was 25, the arc must be 50. If we know the angle was 20, then the arc must be 40. Okay, so it works both ways. It's a two-way street here. Okay, so let's say I have this example. Take a second. Find what this measure x would be. Okay, hopefully you got your answer of 75 degrees would end up being it, because the intercepted arc would be 150. That means that the inscribed angle would be half of 150, which would be 75. Okay, so now take a second to find the measure of angle x, if you can. Now, one thing you probably have noticed is that both of these inscribed angles encompass the same arc. So if they encompass the same arc, that means that those angles should be the same. So that means that x would have to be 85. And this is true for any of the angles. So if I took a point here and went down to here and then went back up to here, that angle that I just drew would also be 65. If I took this one over here and went all the way over here and then up, that angle is also 85. 85, not 65. 85. So no matter where I put it on that circle, if those are my endpoints, it has to be 85 facing that way. Okay, so you can move it around. That angle doesn't change; it stays. Okay, so take a second to find the measure of that inscribed angle. Now remember that the total circle must be 360 degrees, so you would subtract out 90, get you 270, subtract out 80, get you 190, so you take half of that, which would put you at 95. Okay, so this arc ends up being 190 degrees, or 190, and then you'd cut it in half to get the inscribed angle. Okay, so now this next one, so C is the center, that red line's the diameter, so take a second, see if you can figure out what the angle x would be. Yes, it is a right angle. So it is 90 degrees. And this is true for any triangle that's on one half of a circle. If its endpoints are the endpoints of a diameter, no matter where you draw it, it will always make a right angle. Okay? So you'll always make a right triangle. So that's an easy way, if you have to draw a right triangle, is to draw a circle, draw the diameter, and then just draw lines from the endpoints of that diameter to some point on one half of the circle. Okay, and it's always going to make nice little right triangles. So nice. Okay, so the measure of an angle formed by a tangent and a chord is always half the measure of the intercepted arc. So it's the same process, but this time we're talking about a tangent line and a chord. And we're talking about this angle right here. So if we know the intercepted arc, you cut it in half, and that's going to be the measure of that angle. Same as it's true the reverse. If you know the angle, you double it to find the intercepted arc. So if the intercepted arc was 100, that means that this angle must be 50. Okay, for all that stuff. Okay, so take a second, find W, X, Y, and Z. Okay, find W, X, Y, Z. W is probably the easiest one to find, and then X. then Y, and then Z. Okay, hopefully you found all that. So here's your homework, okay, from the section. You want to get to it, you want to do it, you want to go huzzah, and get it done.